Today we're down in Gippsland. We've travelled 3 hours to the east out of Melbourne into what is, lush beef, dairy and farming and wood country. This is a great house for us to introduce to you. It was part of the Sustainability Victoria's 7-Star Home program. We've gone through the process during the construction of this house to provide tips and guidance to the owner and the builder to get the building envelope performance to its best possible performance characteristics. So we focused on insulation, air tightness, and when we do that, we look at the building health and ventilation requirements. So where we've started from is a fantastic design. It's well orientated to the north, as you can tell, with the windows and the shading. So it's allowing the winter light into the house via the shading elements in the house. So the design was well resolved by Darren Evans of Solar Solutions. The build was carried out by Ivers Construction. So that's Matt Ivers. He's a local builder here in Bairnsdale. So I'm going to say from the pictures I saw during construction, the building part of the program I think was well looked after by Matt because he loves what he does and he looks after the projects well. Then I've got a very passionate client. It doesn't happen without a client or a homeowner that has the passion to actually implement into a house not only the design, what you can see, and it's the lovely joinery and the layout and the cabinetry, but what we tend to want to look at is what's happening within the walls and the roof and the ceiling cavities. So at the end of the project, when it's completed, Sustainability Victoria, we come along and we do an as-built verification of the project. So we actually come in and really for the first time, we do thermal imaging of the house just to assess the performance and the install of the insulation. And we do a blower door test just to understand the air tightness of the house. So air tightness is a little new in the industry currently because unless a building is reasonably airtight, you're just allowing in winter, the cold, harsh environment to blow in through all the gaps and the cracks in the building. And in the summertime, you're allowing that hot, uncomfortable environment to filter through the building as well. And together with that, look, you're in a grassy environment. It's all to do with allergies and hay fever and pollution in the city. So if we can make a building envelope that is reasonably airtight, the Building Act requires 10 air changes as a guide. We were always aiming in our work when we're consulting to aim for at least 5 in a house, 5 air changes per hour. This house has actually achieved a phenomenal result. It actually got down when we tested the house at the blower door stage at the end, it actually achieved a 1.3 air changes. Now that is a phenomenal result and it was only achieved through using the plasterboard as the airtight layer. Plasterboard, it's an effective airtight layer, but when managed to the degree that this house was by the owner and the builder, Ivers Construction and the owner Vincent, they actually were able to work the detailing of sealing the plasterboard to the degree that I believe this is one of the most airtight houses using plasterboard because I haven't seen one that's achieved less than 3 air changes. So at 1.3, a phenomenal result. It's a beautiful house in respect that it is really quite a simple house. It hasn't been over-architected to death, but what it's achieved is a fantastic building performance focused on the envelope. What's your passion behind achieving a house to this quality?
So my background is French and having lived most of my life there and arrived to Australia, I thought the houses were not that comfortable, especially in winter. And we've got so much sunshine and we've got a lovely place to live in, but the houses they feel not that great. And so I thought, if I'm gonna build a house, maybe I can look into it to make it the way I want it and just a little bit more comfortable than what I experienced so far.
You contacted Efficiency Matrix and we gave you some guidance 12 months or more ago. And that was great because you were switched on to our point of view in life, which is let's look at the building envelope, let's review the insulation, the building construction, the materials, the building wraps, thermal transfer, let's look at thermal bridging issues, let's look at the window performance, let's look at moisture management. Vincent, the external wall construction is pretty typical of most houses, 90mm stud, but there's always some tricks we can add to overcome some of the issues around a simple 90mm stud wall.
Yeah, that's right. So even though it's a typical house construction with 90mm studs, we have some steel columns going through this wall to support the louvers outside. And so we had the issue of a thermal bridge issue where the heat and the cold can transfer through this steel that's just behind the plaster there. So what we've done on top of the 90mm bad insulation, we've added this floorboard, which basically is helping to break the thermal bridge that we have behind those walls.
Similar to the walls, I always have a problem with cathedral ceilings because the roof beams are generally not overly deep. We're limited to the amount of insulation we can install. In this case, you've introduced the insulation, and just tell us what you did with the ceiling.
Yeah, that's right. So with the traditional ceiling bat here, we got R4, a little bit more than that. So what we've done, we introduced the continuous floorboard as well all along the ceiling, and that's gives us another insulation layer, but it also ensures that we have continuous insulation happening in the cathedral ceiling, which was very important. Overall, it's giving us R6 in the ceiling, which is what we want.
Continuous insulation is going to be far more beneficial than loading the roof up with more and more glass wool. We're in the flat ceiling sections of the house now, so either side of the cathedral living room we've got bedrooms, flat ceilings, roof trusses, so we've got a nice roof cavity. So it gives you the opportunity when you're insulating a ceiling, and this is something we spoke about, is to put the insulation in 2 layers. So this is one of my little tricks, is that in the bottom chord of the trusses, so you've got your trusses with a 90mm bottom chord, lay a 90mm layer and then go and put your second layer over the top in the opposite direction. So 2 layers. Again, second layer goes across the top chord to knock out the thermal bridging. It's just the obvious solution to flat ceilings when you've got plenty of room for insulation. One of the key strategies to the building efficiency is air tightness. It's one of the real focuses under the Sustainability Victoria 7-Star Homes program. And we've done the blower test, and believe it or not, it's one of the most airtight houses, or it is the most airtight house having used plasterboard. So one of my little philosophies on air tightness is it doesn't have to come at a huge cost. Plasterboard is existing, it sits there, it's everywhere, walls, ceilings, and as long as it's continuous behind all your cupboards and becomes a continuous airtight strategy, all you've got to do is seal it airtight. We spoke about the tips and tricks, but just give us an insight to how you went about sealing all this plasterboard airtight.
Well, that's right. With the plasterboard, it's an easy concession to have with the builder. It's something they can work with, and just using caulking silicone guns, those kind of things that are very simple and inexpensive. Or just having the concession with the builder, I was like, yep, I can get onto it. I'm going to ensure, and I'm going to talk to all the trades, the electricians, the plumbers, to make sure that all penetrations are sealed before the cabinets come in, before the house is painted and so forth. So it wasn't a difficult thing to do. It wasn't out of the ordinary. So that's something the builder could come on board very easily, and they achieved the result with not much supervision. They just did it by themselves and got to where we are now.
So you gave them guidance, and the builder went along. See, this is where Matt Ivers and his team must have done a fantastic job. The problem I have with these houses is that they get so many different contractors in, he just loses control. So that's the first thing. Attention to detail must have been fantastic, because to get a 1.3, I'm nearly going to say the windows and doors will leak a little bit. So I'm going to say you probably get an air change out of windows and sliding doors that leak. So I'm going to have to nearly say the plasterboard must be nearly perfectly airtight to get down close to 1. A miraculous result.
We found one gap after the test was done, and we could have gone better, but we aimed for perfection, and we got pretty close to, or much better, I would say, to what we're expecting anyway. So it's a fantastic result.
That's right. Well, it's the best result we've ever seen. If you can get down to under 3, it does warrant a ventilation system.
To me, the HRV is just a matter of ensuring we always get fresh air in the house. And it's not, we don't have to open the window in the middle of winter and get all that cold air coming in. It's the system is doing it for us. We don't have to put too much thought and effort. And we know that it's just going to get just enough fresh air, in summer and winter.
I'm just going to show you, because it's actually telling us that you've got to change your filter. So that's what we're looking at. So funny, it's filtering the air from outside, and that's the dirt and the pollens and the dust and the pollution it's extracting out of the air. So this gives you an idea how much sort of cleaner the air in the house is straight away. And of course the house is actually a consistent temperature because every room is ventilated by this unit. I think they're fantastic. I just don't know why they're not a permanent addition to every home. So just one of the little scenarios or the issues that I've found with building design when introducing HRV, which is great, is the issue of accommodating the ductwork. The ductwork is not insulated, it's just plastic. It's a flexible plastic ductwork. It has to be located within the building thermal envelope. You can't go up into roof spaces that become 0 degrees in winter and 60 degrees in summer because there's no insulation to this ductwork. It would defeat the purpose of what's called the energy harvesting of the heat recovery ventilation unit. So you've got to actually locate this within the thermal envelope. That means below the ceiling insulation, which I'm going to say means you've got to drop a ceiling down, maybe 200 mils to accommodate this ductwork. So that's just a consideration. In this house with Vincent, we actually sort of lowered the ceiling height across the service area at the back of the house. So we created this 200 mil zone below the insulation to run all this ductwork backwards and forwards from one end of the house to the other. You moved in May, so you've actually been in this house through the worst of winter. So how does it feel?
Well, this is basically what I'm wearing on a daily basis, just a t-shirt. And I work from home and I can see people on the camera, on the video conference, they're all wearing jumpers and many layers. And all through winter I've been wearing just a t-shirt and opening the window actually to get a bit cooler sometimes. And it's been a fantastic feeling in the morning, just jumping in the shower, not being cold, just doing all daily normal things without having to think about being cold at all. It's just comfortable all the time.
To get this level of performance out of the house, you've had the passion and you've had the vision, and by good design, Solar Solutions, Darren Evans, and then Ivers Construction, Matt Ivers has done a fantastic job to get that level of air tightness and insulation consistency we've seen. Efficiency matrix, I've given you tips, clues and tips along the way, and you've actually adopted them, which is fantastic. And then of course the Sustainability Victoria 7-Star Homes program is the sort of ambition of that program is to create sustainable homes to this level of comfort, and it really is not that difficult to achieve. So it's really become the model for Sustainability Victoria and that program to basically reproduce houses like this one that are performing as comfortably and as energy efficiently and reducing carbon emissions and very healthy in respect that they're managing moisture and ventilation. So there's a whole heap of boxes ticked. To us, we just don't know why every house doesn't literally perform as well as this one. Congratulations.
Thank you.
Huge effort. Good work.
Thanks, Mark.